Our next notion with dealing with continuity and continuous functions is we're going to look at it from the other side of the coin. Rather than trying to find where the function is continuous, we're going to try to find those values where the function is not continuous. Where is the function not continuous? Remember, a function is not continuous if it has a whole, jump, or vertical asymptote. Whole, jump, vertical asymptote. For our purposes, that's the notion of the functions we've considered so far. Those are the discontinuity types: holes, jumps, vertical asymptotes. Holes, they're called removable discontinuities. Jumps are called jump discontinuities, very creative there. And vertical asymptotes are called infinite discontinuities because the curve goes off to infinity at the asymptote. And so we want to find the values where the function is not continuous. Value or values. There might be one, there might be more than one. So let's start with an easy case. Where is this function not continuous? This is a rational function. We know rational functions, they are continuous on their domains, so they are not continuous at any value not in the domain. So our task to find where it is not continuous is to find the values where this is not. Find the values of x that are not in the domain of this function. And for fractions, the key notion is you're not allowed to have denominator equal to 0. If it is not obvious, all you need to do is this: to find the values to be excluded, set denominator equal to 0 and solve. We want to find the value or values where this function is not continuous. You establish the condition to be met, denominator equal to 0, back solve to find where that occurs. And so, if it were not already obvious, we would say you must exclude, this implies x is equal to -6. My arrow just means implies. You don't need to write my arrows. The arrows implies. It got beaten into my DNA by my math instructor when I was a math major in college, and that ship has sailed. So I just write my implies arrows. This statement implies this statement. That's just who I am now, for better or worse. So x equals -6. So find the values where the function is not continuous. You would say not continuous at x equal, what was it, -6. All right? Now, there might be more than one because the function might be more complicated. We might have f of x equals 3 over, let's say 3x plus 1 over x to the third minus 9x squared. Now the numerator equals 0 and -1/3, but we don't care if the numerator is equal to 0. All we want to find is where the denominator is equal to 0. So we would do the same process. So we must exclude. What values need to be excluded from the domain? The domain is all the real numbers except the values we need to exclude. So we must exclude where x to the third minus 9x to the second is equal to 0. Factor that within an inch of its life. X squared times x minus 9 is equal to 0. We have x is equal to 0, x is equal to 9. So this is not continuous. At x equals 0, x equals 9. Okay? So for fractions, it's straightforward. Find the values where the function is not continuous. For fraction functions, set denominator equal to 0. Those are the values that must be excluded from the domain. Those are the values where the function is not continuous.